Welcome back. Today is day 2 of our right triangles unit. In this lesson, we'll find the side length of squares on the coordinate plane. Hope you enjoy the video. Alright, so for our lesson today, I gotta give some props out to Sal Khan. Thanks, Sal Khan, for this video. Really helps my students understand the formulas and where they're coming from. Great job with this. Link is down so you can watch that later. Also, here's the formula. So again, copy these down into your notebook. So let's get these down, and that way we have those. But the video does a great job showing the rectangle, parallelogram, and triangle and how they're all related. So make sure you guys watch that video so you guys can see that. And then you can use the same method that Sal has used to actually come up with that formula there for a trapezoid. You can use the exact same method to kind of see what he's doing there. All right, it's actually really cool. But let's get to our problem. So our problem today is a nice little problem solving. I usually let my students try this out for the first time by themselves and see how far they come along. And so the other day I saw an interesting method of how to do this. So it says find the side length of square ABCD. All right, round your answer to the nearest tenth. Here's a link to GeoGebra so you can check that out if you need to. And that really helps out because a lot of students, sometimes my students say they just count like this side is, they go 1, 2, 3, so they say this is 3. So the GeoGebra app, it'll just rotate this square and show you that it's actually it's bigger than 3. It's not 3. All right, but so that's all the GeoGebra app does. But so for this problem, I saw my student do this the other day. So this is how they did this problem. So the first thing they noticed was, well, they're trying to figure out how are we going to find the side length. All right, and there is faster ways in math that we can do it, but for right now, we don't know any faster ways, so we're going to have to go back to what we know. We know that if we can find the area of the square, so you can figure out what the area is, then you know the side length. So for instance, remember if we had an area of, like if we had a square, like in our first problems from the other day, and the area is 25. So if we knew the area of this square is 25, then we can quickly just take the square root of that and say, okay, well, the square root of 25 is what? That's going to be equal to 5. So my side lengths are going to be 5 and 5. So we're going to use the same kind of process, but on this problem, this square is the area is not easy to count. And remember what area is, so that's why I really like this problem. So the other day, my student did it this way. This is how they did the problem. So what they mentioned was they noticed that one square, this square is 1 unit. So they're basically going to start counting units. So what they said was, if you take this one and this one, these two squares right here, they're exactly half a square. So that is 1 unit. So they took those two right here and they said that's 1 unit. All right. And then they said, well, I could do the same thing with these two over here, and this would be 1 unit. And I can do the same thing with these two right here. So they're basically taking all these halves, and that's another unit. They're taking this half with this half, so these two together, they're saying that's 1 unit. And they're taking these two together, that's going to be 1 unit. So they took all the half units and made them into whole units, and they just counted up each half unit until they got their area. So here's what they said. So all those little triangles, they counted those up and they said 1, 2, 3, 4, 5, 6. So all those little triangles, let me draw one of them, is equal to 6 units. So that's the first thing they did. Unit squared. All right. And then, so now that they have those, then they decided, you know what, we can cut this into some pieces. Like they saw there's a rectangle here, and they saw really quickly they can count up those, and that would be another 8 units there. So the rectangle would be another 8 units. And so they did that one. They also noticed that, well, we have 2 units here that we haven't accounted for, so there's 2 more units there, and there's 2 more units down here. So I'm going to say 2 times this one. So they actually did 2 times 2, which is 4. So they got their units. So all my units, this is how they did the problem the first time. All right, so That works. That's a great method of doing this. So that's going to be 10, 18. So they found out that the area of the whole square, so the area of the whole square is going to be 18 units squared. So now, real simple, how do you find the side length? So now that we know what the area is, we can just do what we've been saying. So we can take the square root of 18, and the square root of 18 is going to be approximately what? What's the square root of 18? And again, that's not a perfect square, so we're going to get a decimal value for this one. So what do we get? Square root of 18, and it comes out to about 4.24. Perfect. So how long are my sides? 4.24 units. So each side, if I was to write it out, 4.24. So this is how they did this problem. But on the next ones, we're going to try some other methods. Well, I don't want to be counting up all the little pieces. Maybe we can try some faster methods. All right, so let's try problem 2. Problem. We're going to do the same. We're going to do the same method of trying to find the area of this square, but we're not going to cut it into such small pieces. We're gonna actually look for bigger pieces. And so one way of doing this, there's a whole bunch of ways of doing this, but one way of doing this problem is to, if you can see, I see a triangle right here. So there's a triangle. Do you see that triangle? It's a right triangle. There's one right there. That's pretty beautiful. And let me continue down here. Whoa, it's a little messy. I'm going to stop here because I'm going to get to there. I'm going to keep drawing right triangles and I'll show you why in a second. So I see a triangle right there. That's beautiful. I'm going to continue on over here. And this is a hard one to see. So I'm going to cut this into, and what I did was, if you notice, I've cut this into 5 pieces. I got 5 pieces, and I'm going to draw one of those triangles. So one of those triangles that I cut this into looks like this. So I'm just drawing the top triangle. But the cool thing about this, all those triangles were the same. So if you count your side lengths, how long are each sides of my triangles? This is 2. And if I count my units over, 1, 2, 3, 4, 5, 6, this would be 6. But every triangle is the exact same size as that. So now, much quicker method would be, now let's find the area of this one triangle. So the area of this one triangle is going to be 1/2 base times height, thanks to our con video. And so I know my area is going to be 1/2 6 times 2, so that's basically 12 divided by 2, which is 6. So the area of this is going to be 6. So what that tells me is we just found the area of this triangle, and the area of the next triangle is going to have the same area. This is 6, and the area of this triangle is 6 also, and the area of this triangle is 6. So very cool. So very, very cool. If I can cut this into pieces that are going to be congruent pieces, then this works out nicely. And then what do you see on the inside here? So on the inside of this, I see a square. So I see a square that's plopped right in the center of this right here. Here we go. There's a square, and it looks like that square is 4 by 4, which has an area of 16. So the area of the square, I'll write it over here. So I'll make it a little small. So my square, it was a 4 by 4. So this one's going to be area, remember area equals side squared, which is going to be 4 squared, which is 16 units. So there we go. So what's the total area for this square? Well, my area is going to be, for the square, is going to be, the large square is going to be 4 times 6, because we have 4 of those triangles, then each one was 6, plus the 16, plus the 16 units for the square in the center. And again, a lot cleaner this time, instead of counting every little part, and especially since these aren't getting cut exactly in half. So this one's a lot cleaner and a lot nicer. So the area of the huge square is going to be 24 plus 16. What is 24 plus 16? That's going to be 40. So 40 units squared. And now again, how long are my sides of this square? Because that's what I really want at the beginning of this problem. So now we need to do what? We need to take the square root of 40. So what is the square root of 40? And it is approximately, let's do that really quick on a calculator. It is approximately 6.3. So around 6.3 units. All right, and there we go. That's how we do it. So again, on this next problem, try to do a method like this. Try to decompose it into a shape that you actually can find the area of and see if you can figure it out. But a very cool problem. Probably another one that really hurts your mind when you're like, how can I cut this apart into different pieces? But I'm going to show you a different method right now of doing this. So again, you can try cutting these apart into different pieces, or you can try other methods. And that's the beauty about these problems that we have here. There's a bunch of ways of doing this problem. So sometimes my students, like for instance, will do this problem differently. So for instance, instead of doing the problem and trying to cut that apart, they will actually do this. Let me show you. And this is another method that is really cool and will do the same thing. So what they do, check out what they did. They constructed a larger, is that a square? Let me see. 1, 2, 3, 4, 5, 6, 7. Yes, 1, 2, 3, 4, 5, 6. Yeah, they constructed a larger square around the square that they already had. And then they find the area of that. So the area of that square is going to be 7 squared, which is 49. So guess what? They have the area of this large square. And then the reason they did this, because it made it easy for them to figure out these pieces here. So these triangles right here. So they found these little magenta triangles. They're like, okay, we can find the area of these ones. Really simple. And this is a beautiful method too. A few of my students did it this way. It was really nice. And it's nice to see them thinking critically here. So now they did it this way. So they actually constructed a larger square, and then they found these magenta squares here. Let me draw one of those out. So let's draw the one on the top left. And count the units. So that's 1, 2, 3, 4. So it's a 4 by 1, 2, 3. 4 by 3, and let me see, I think they're all the same. 1, 2, 3, 4, a 4 by 1, 2, 3. Oh, a 4 by 3, a 1, 2, 3, 4, 1, 2, 3. Oh, all of these are 4. They're exactly the same. So what they did was they cut into, again, 4 congruent triangles, and then they found the area of this one really simple. So they said area is equal to 1/2 base times height. Pretty smart kids. And multiply 4. And here's what they did. So they said that's 12 divided by 2, which is 6. So they found the area of this one, which is 6. But then they had also 4 other ones that were exactly the same as that. And now, so how do they end up coming up with the answer? Well, what they did to find the blue part right there, all they did was took the area of the large square. So they took the area of the large square, and then they subtracted, I'm going to write it like this, the area of the 4 triangles. Okay, so that makes sense. They took the area of the large square, which was 49, and they subtracted 4 times the 6, because there's 6 triangles. And the leftover amount from that is going to be your answer for the blue square. So this is 49, subtract 24, which is 25. What the heck? Actually, the area is 25, and what's beautiful about this problem is how long is each side? Well, we know that we can take the square root of 25. This one doesn't even have a decimal. That's beautiful. So 5, 5, and 5, and 5. All right, perfect. So again, a beautiful problem, another way of doing this problem. Again, I like what I see here.